Hello class, today's lesson is lesson 5-7 in your algebra textbooks, and the title is teaching you how to graph linear inequalities in two variables. Now you're very familiar with ordered pairs, the x and the y value, and also equations that have an x and a y variable in it, but now we're going to look at it with, instead of having an equal sign, as an inequality. So for this first example, we have x minus 3y is less than or equal to 6. And I'm going to give you a couple of coordinate points, and I want you to tell me if it is a solution of this inequality. So let's just start with 0, 0. If I plug that in, I'm going to put 0 for the x value minus 3 times the y value of my coordinate is 0 as well. And I want to see if that is going to be less than or equal to 6. 0 minus 0 is still 0. So now I need to take a look. Is 0 less than or equal to 6? Yes, it is. So that means this point, 0, 0, is one out of hundreds and thousands of solutions for this inequality. So let's try another point. How about 6, negative 1? All right, so the same process that I did before, I'm going to plug in. So for my x value, I'm going to plug in a 6 minus 3 times negative 1. And I want to see if that is less than or equal to positive 6. So let's see here. Negative 3 times negative 1 is positive 3. And 6 plus 3 is 9. Now, is 9 less than or equal to 6? No, it's not. So this is not a solution, the 6, negative 1. All right, and we're going to be able to find many, many more solutions, but it's actually too numerous for us to list all of them when you have two variables, the x and the y. So what we're going to do on the next page is we're actually going to graph these inequalities, and you're going to see what they look like on a coordinate plane. Now, some of the things that I want you to realize when you're graphing, the first thing is just think of it like it's an equation. So graph the same way you did when you had an equal sign. Okay. So you're going to look for the slope, you're going to look for the y-intercept, all right, and that's going to be the first step. Then you're going to look at the inequality. All right, if it has a less than or if it has a greater than, instead of putting a solid line, you're going to put a dotted line. Okay, and then if it has a less than or equal to, or if it has a greater than or equal to inequality, it will be a solid line. Okay. So that's kind of the second step in being able to graph an inequality, is just what type of line are you going to draw. And then the third thing that we're going to do, because I said that there's hundreds of thousands of different solutions for any inequality that you're given, is that you're going to pick a test point. So pick any point, plug it in, and if it's true, then you will shade that area. And vice versa. If you pick a coordinate like 6, negative 1, and you find out that it's false, you're not going to shade the area that 6, negative 1 is in. So why don't we try this out? I have here a problem, graph y greater than 4x plus 3. So what I want to do, like I put for those little helpful hints, is pretend like it's the equation y is equal to 4x minus 3. And I want to graph this equation. Now looking here, I can see that it's going to cross the y-axis. This is the y-intercept at negative 3. So I'm going to start there, negative 1, negative 2, negative 3. Put a big dot there. Okay. My second thing is I'm going to look at the slope. and it's written in slope-intercept form. So the slope is actually 4 over 1. So this means from my y-intercept, I'm going to go up 4, 1, 2, 3, 4, and over 1. That's my rise over my run. I have my 2 points. I'm ready to draw my line, but I need to look. It is greater than. It's not greater than or equal to. So thinking back, that means I'm going to draw a dotted line. So instead of a solid line, I'm going to draw a dotted line with my ruler. So I am almost done. There really wasn't much work there that I had to do, just using all the knowledge that I have from graphing equations. But the final thing that we said was pick a test point. So for this one, I'm going to pick this point right here, right at the origin, 0, 0. So this is going to be my test point. And what I'm going to do is I'm going to plug it into this top inequality, and if it's true, then this section, this half of the line that has that point is what I'm going to shade. If it's false, then I'm going to shade the right side. So let's plug it in. 0, I want to see if that's greater than 4 times 0 minus 3. Let's do a little work. 4 times 0 is 0 minus 3. And that is just negative 3. Now I'm going to ask myself, is 0 greater than negative 3? Yes, it is. So that means this point is going to tell me what side of my line I'm going to shade. So I'm going to shade this entire left-hand side. So as I was telling you before that it has infinite number of solutions, look at all of these possible coordinate points on this side that are solutions for this inequality. So why don't we do another one? Let's get some good practice at this. The next one is x plus 2y is less than or equal to 0. Now this is not written in slope-intercept form, so I'm going to do that myself first. It just will help me out to find the slope and to find the y-intercept. So I'm going to subtract x on both sides. And that's going to leave me with 2y is less than or equal to negative x. And I still want the y by itself, so I'm going to divide both sides by 2. And now I'm left with y is less than or equal to negative 1/2 x. So I've rewritten it in slope-intercept form. I'm going to kind of pretend like it's y is equal to negative 1/2 x. And I'm looking and I don't have a y-intercept. If you recall, this means that I'm going to notice that my line is crossing at 0. It's almost like there's an invisible plus 0 here. So that is the y-intercept. From this point, I'm going to go down 1 and to the right 2. So I'm going down 1, and then I'm going to the right 2 points. 1, 2. I'm going to put my point right there. And I have my 2 points to form my line now. Now let's look back at our beginning inequality. It is less than or equal to. Since it has that possibility of being equal to, I am going to draw a solid line. So there's my line. And now, just like we did before, we're going to pick a test point. So maybe I'm going to pick this point right here. This is 2, 1. So I'm going to pick the point 2, 1, and I'm going to plug in those values into my top inequality. So the x is 2 plus 2 times 1. I want to see if that's less than 0. So this is 2 plus 2. Is that less than or equal to 0? No, it's not. 4 is not less than or equal to 0, which means I'm not going to shade the side of the line that has this point. So I'm going to shade the opposite side. So this shaded section, again, is showing me all of the possible solutions for this inequality. Okay. Now, sometimes lines might be horizontal or vertical, and we know that when that happens, from our experience in the past, that there's only one variable left. So what I'm going to do is, just like if it were y is equal to -3, I'm going to graph this line. Now this is telling me that the height of my line is where y is equal to -3. So it's going to be right up here, oh, I'm sorry, right down here at -3, and I'm going to draw my line going horizontal. Okay, and let's see, looking here, it is going to be a solid line because it is greater than or equal to, so I'm going to draw my solid line at -3 on the y-axis, going all the way across horizontally. And then, just like I did before, I'm still going to pick a test point. So why don't I pick 0, 0? This is a really easy one, okay? But if you notice, I don't have an x value up above. So the only thing that you're going to plug in is the y value. So let's test this out. Is 0 greater than or equal to -3? Yes, it is. That's true. So again, I'm going to graph this half of the line that has that test point on it. So I'm going to shade, I'm not going to graph, sorry, I'm going to shade everything that has that test point on it. So why don't we do one more? The last one is y is less than 1. All right, so if you recall, this is very similar to x is equal to -1. I'm sorry, I did not say the negative. So x equal to -1, that's what we're thinking of. And we know that when it's x is equal to a number, that this is actually going to be a vertical line, and it's going to be crossing the x-axis at -1. So I'm going to draw my line, I'm going to get my ruler ready, and I need to check again, is it going to be a dotted line or a solid line? Since it's just less than, it's going to be, oops, and I messed up already, it's going to be a dotted line. So on your paper, I better see a dotted line. There we go. Awesome. So you can kind of tell that it's a dotted line. I'm going to emphasize that a little bit more for you guys. So I have my dotted line, and when I'm looking at this, I'm actually going to be graphing all of those possible points that are going to be the x value is less than -1. So think about that. You're still going to pick a test point, so why don't we pick this point right here, 3, 1. This is going to be my test point. Now again, looking up here, I only have one variable. It's the x variable. So I'm only going to plug in the x coordinate. So let's plug this in. Is 3 less than -1? No, it's not, which means I'm not going to shade the side that has that point 3, 1. So instead I'm going to shade the left-hand side that does not have that test point on it. And I'm done. And this should make sense because it's talking about all of those x values that are smaller than -1, so like -2, -3, -4, -5, and so on. So what I'd like you guys to do before you come back to class is to just try one equation to graph it. So again, I think that it's a best practice to rewrite this inequality so that it is in slope-intercept form, and then practice those same steps. You know, graph it just as you would an equation. Notice if it's going to be a dotted line or if it's going to be a solid line. And then once you have that line graphed, pick a test point and shade the area if the test point is true. And I will see you guys tomorrow.